Okay, sorry about the interruption there in the short video, but we'll keep on keeping on here. Okay, so that means we have 2 nitrogens, 8 hydrogens, and 1 oxygen. Get back into my chemistry flow here. 1 times 16 equals 16. 8 hydrogens is 8, and 2 nitrogens times 14 is 28. So we have 28 plus 16 plus 8, 52. 52 grams per mole. Actually, I should put units here. Good work habits. Okay. Use the unbalanced chemical equation to answer questions 14 through 16. Okay, so first we're going to balance this thing up. I'm going to do, well, let's see. Yeah, we can do that. 3, 2, 3. Okay, seems like we're balanced. I'm not going to do any atom counts. I'm just going to look and see that 3 calciums, 3 oxygens, 2 aluminums, and we're good. What is the mole ratio between aluminum and calcium? Well, that's simple. It's 2 to 3. 2.3. What's the mole ratio between calcium oxide and aluminum oxide? So that's 3 to 1. Simple stuff. Okay, so let's move down. A student places chemicals from above in a bag and allows the reaction to take place. Use the law of conservation of mass to complete the chart below. Mass of reactants, mass of products. Well, law of conservation says that whatever this is going to be, because you cannot create or destroy. Matter. So what we have to do is add this up and this up. So I've got, and I would accept it either way, either with the coefficients or without the coefficients, but I'm going to do it with. So I have 2 aluminums, which weigh 27 apiece, plus 3 calciums, which weigh 40.1 apiece, plus 3 oxygens, which weigh 16 apiece, and I get 222.3 grams, which means I get 222.3 grams in the product side. Law of conservation dictates that whatever I have to begin with, I'm going to have in the end. Okay. All right, page 1 is done. Let's flip this thing over and see what we got for page 2. Okay, which of the following formulas is an empirical formula? Okay, so what we're looking at is whether or not there's a common factor. Well, there's a common factor of 2 there, and 2 there, and 2 there, and I see this 11 here, so this has to be my empirical formula. There's no common factor for 11, 22, and 12, so that is the lowest common factor right there. So that's B. Caffeine has the following percent compositions. Calculate the empirical formula. Okay, this is going to require some paper. So let's go to here. Now, remember the first thing we do is we call these grams, right? We have 49.48 grams of carbon. We have 5.19 grams of hydrogen. We have 16.48 grams of oxygen, and we have 28.85 grams of nitrogen. And then we're going to figure out the molar quantities. So instead of doing a dimensional analysis for each where I have grams in the upper corner and grams down here in 1 mole, I'm just going to divide by the molar mass to make this a little faster. Molar mass of 1. So this equals 5.19 moles of hydrogen. Oxygen divided by 16. So 16.48 divided by 16 equals 1.03 moles of oxygen. And then divided by 14.
Christine Rainwater, please call 7616. Christine Rainwater, please call 7616.
14 equals 2.06 moles of nitrogen. And 49.48 divided by 12 equals 4.12 moles of carbon. Okay, so then we take our lowest mole total, which is 1.03. This has 5 moles, 4 moles, 2 moles. 1.03 is our lowest mole total, and we divide by that. So 1.03, so we have nitrogen 2. We have oxygen 1. We have 1.03. We have hydrogens 5 and 1.03. We have carbons 4. So we have C4H5ON2. And that is our empirical formula. C4H5ON2. Okay, what do we got next? The following balanced equation shows the formation of aluminum oxide. How many moles of oxygen are needed to produce 10 moles of Al2O3? So now we're finding two different things. So it's boxes, and it's a moles to moles. So it's 1 box with the mole ratio in the middle. Okay, so let me get a fresh piece of scratch paper here. Okay, let's do this. So we have 10 moles Al2O3, single box, and whatever units our answer's in, which is moles of O2, it's going to be the same units up here. Units that we end in are the units in the upper right box, always, always, always. Units that we begin in are going to have to cancel down here, so we have moles of Al2O3. So this is the heart of the problem, or the mole ratio, so we need to start looking up here at our equation and seeing what we have. So moles of O2, it looks like we have 3 right there. Moles of Al2O3, we have 2 right here. 10 times 3 is 30, divided by 2 is 15. 15 moles of O2. That's your answer. Seems fairly simple. Okay, next. And then they're going to give us a grams to grams problem. So that's a 3-boxer, right? So we got to do 3 boxes. 1, 2, 3. And we're starting out with 50 grams of O2. 50 grams of O2. Oops. We got to move this down a little bit. Okay, there we go. 50 grams of O2, and we're going to end up with grams of water. So grams H2O. So we know this upper right box, grams H2O, because whatever units our answer's in, units up here. We know that when we see grams anywhere, whether it's on bottom or on top, on the other side is 1 mole H2O. And since units cancel diagonally, we know that this is moles H2O. Right? And that's as far as we can go backwards because there are no rules about what's below moles. So we have to continue from this side. So these units have to cancel here. So we have grams of O2. And anytime we see grams, immediately 1 mole O2, which means this is moles of O2. Whenever I see moles over moles, I know that's the heart of the problem. And I start looking up here and seeing that I have 2 moles of H2O for every 1 mole of O2, and grams of O2, so that's 16 times 2, which is 32 grams of O2, and then grams of H2O. By now I would hope you memorize that it's 18, and then it's just a math problem. So we have 50 times 1 times 2 times 18, enter, divided by 32, enter, divided by 1, which means that I have 56.25 grams of H2O. 56.25 grams H2O. All right, so we've done a moles to moles and a grams to grams. Let's see what else they've given us here. Okay, use the following balanced equation to answer question 19. All right, how many grams are needed to react with 1.5 moles? So we're going from moles. We're going from moles to grams. So from moles to grams, how many boxes? Hopefully by now you know. We have 2 boxes. And we have 1.5 moles of sodium hydroxide, NaOH. So that makes this moles NaOH. Shouldn't have crowded it in here, but I did. Oh, I'll move this up a little, don't we? Okay, moles NaOH. Moles NaOH, and our answer is in grams of sulfuric acid, grams H2SO4, which means this is grams H2SO4, which means this is 1 mole H2SO4. Ugh, I hate this writing so messy. Which means this is moles H2SO4. And whenever we see moles over moles, we know that's the heart of the problem. That's the mole ratio, always going to be part of every problem like this. So moles of NaOH, we have 2 moles of H2SO4, we have 1, and then we just have to figure out the grams of H2SO4. So we got to do some calculation. So sulfur is 32.1 plus 2 hydrogens plus 4 oxygens, which are 16 apiece. That makes this 98.1, and then it just becomes a math problem again. 1.5 times 1 times 98.1, enter, divided by 2, enter, divided by 1, enter, 73.57. Now I say that I'm dividing by 1, but I actually am canceling those out. So I'm just doing 1.5 times this, divided by 2. 1's go away, so this is 73.57 grams H2SO4. All right, and we will continue after I cut this video.